Hello and welcome to another episode of Math with Dr. War. Today we're going to be solving linear inequalities. Solving linear inequalities is similar to solving linear equations. Your aim is to isolate a variable. The only difference, you do not have an equal sign, you have an inequality sign. My first example, I have x plus 2 is greater than 16. So this is like a one-step inequality. If I have to solve for x, I need to eliminate the 2. It's connected by addition, so I'm going to subtract 2 from both sides. The 2's are cancelled, and my answer is x is greater, and I need to combine the 16 with the negative 2. The signs are different, which means I subtract, which gives me 14, and keep the sign of the larger number. So x is greater than 14. You can have a two-step linear inequality. I'm solving for x, so I'm going to first get rid of my 2. I'm going to add 2 to both sides. That's cancelled. I get 5x is less than or equals. Remember, when the signs are different, you subtract. That gives me 15. Keep the sign of the larger. So it's negative 15. Solving for x, I'm going to divide both sides by 5. As I divide by 5, my answer is x is less than or equals. A negative divided by a positive is a negative, and 15 divided by 5 is 3. I have another two-step, but this one is a little bit different than the second one. With the 5x minus 2, my variable was positive. Over here, my variable is negative. But let's continue to solve for x. So I'm going to eliminate the 7, so I'm going to add 7 to both sides. That's eliminated. I have negative 4x is greater. 1 plus 7 is 8. Now solving for my x, I have to divide both sides by negative 4. Because I'm dividing my variable by a negative integer, my inequality sign will have to change direction. It's not going to be greater than anymore. It's going to become less than. The negative 4's cancel and I have x. And again, when I divide 8 divided by negative 4, my answer is negative 2. So x is less than negative 2. Always remember, when you divide or multiply the variable by a negative, the inequality sign changes to the opposite. And the reason for that is, I'm going to show you. Now, I'm going to write a sentence here, an inequality sentence. So 2 is less than 5, correct? 2 is less than 5. All right, I'm going to go in here and divide both of these by negative 1. When I divide by negative 1, this becomes negative 2, and this becomes negative 5. Now, if I keep that inequality sign, is negative 2 less than negative 5? The answer is no. So we have to use the correct inequality. The correct inequality would be negative 2 is greater than negative 5. And that's the reason why whenever you divide your variable by a negative integer, your inequality sign must change directions. Always remember that. I'm going to do some variables on both sides because we did those with our equations. We can do them with inequalities as well. Remember, when you have variables on both sides, we get rid of the variable that's on the right. So I'm going to minus 3x on both sides. The signs are different, so I subtract. I get 1x minus 30 greater than or equals. This cancels, 12. Solving for x, this is now a one-step. I'm going to add 30 to both sides. This cancels. I have x greater than or equals to 42. Variables on both sides. Always eliminate the 1 on the right. So I'm going to get rid of the 3x. So I'm going to minus 3x on both sides. Now notice what happens. This cancels. Over here the signs are different, so I subtract. I get 1x. Keep the sign of the larger, so it's negative. Plus 8. Don't forget your inequality sign. Greater than negative 6. Solving for x, I'm going to get rid of the 8. I'm going to do the opposite. I'm going to subtract 8 from both sides. I have negative 1x is greater. Always remember, when your signs are the same, you add 14, keep the sign of the larger number. Now remember, we're solving for x, so I need to get rid of that negative 1. The negative 1 is connected to the x by multiplication. So guess what? I have to divide both sides by negative 1. And when you divide both sides by negative 1, the inequality sign must change direction, must change to the opposite. So since this is greater, it becomes a less. This cancels. I get my x. 2 negatives when you divide gives you a positive, and 14 divided by 1 is 14. So always remember, when you divide your variable by a negative, the inequality sign must change direction. 2 multiple choice problems that you may see on your TASC examination. So sometimes you must just solve the inequality. So here it states which graph represents the solution set of 2x minus 5 less than 3. Just go on the side and solve it. 2x minus 5 less than 3. This is a 2-step. Add 5 to both sides. 2x is less than 8. Solving for x, divide both sides by 2. So x is less than 4. So because it's less than, your circle will be open. So we can eliminate number 2. Okay, I'm going to change my pen color for a second. Alrighty. So we can eliminate number 2 because that's a closed circle. And we can also eliminate number 4 because it has a closed circle. 4. This has a 4, so your answer is 1. Notice the open circle here is at negative 1. And there's your answer. The second problem states which number is in the solution set of the inequality. So if we solve this, I have 5x plus 3 greater than 38. So solving for x, I'm going to subtract 3 from both sides. I get 5x is greater than 35. Solving for x, I divide both sides by 5. X is greater than 7. So I am looking for a value that is greater than 7. I have 5, 6, 7, and 8. Who is greater than 7? So my answer is 8. Because remember, an inequality, you have many solutions. Your solution should be greater than 7. Should not be 7, greater than 7. I hope these examples have been helpful. Good luck on your examination.